Okay. Day two. Yeah, we're live. Fantastic. Okay. Day two of Advent of Code should be out because we did complete day one. We can actually just go back to the Advent calendar. That should give us day two. Day two is live. Day three will be live in 13 hours, which seems a little bit longer. Oh, no. It's just because I've started the stream earlier this time. Cool. We will try and attempt to solve day two within the next hour. I'm expecting it should be a lot quicker than that because the weekday puzzles are usually a lot easier, and especially at the start of the, you know, thing, it's going to be a lot simpler to do stuff. So, whoops, I should probably close that. Close. Fuck's sake. Okay. It did close. Okay, that was weird. All right, so cool. Anyway, we should be Um, yeah, I think we can just probably get started. I don't think we're gonna have any of the setup issues from last time or any of that nonsense. We could probably just get started. Of course, music. I keep forgetting. That's like a thing. Let's pull that up. I really actually do want to play some of like the indie tracks I normally listen to. Need to find a way if it's possible to actually have like two separate sort of audio streams so that I can actually redirect my mic into the VOD, but I can keep any PC audio, including the music and all that, going out of the VOD, right, and not really. Again, I don't know if it's possible to redirect it from specific applications because I would like to do it just from wherever I'm playing music, like the browser or something like that. And potentially, if I ever do play games or something on this, then in that case, like I won't really have problems. But I'm suspecting that's probably not possible. But then again, like at least at the very least, I kind of want to make sure that I have yeah. Okay, so that should be music. Um, whatever that sounds like. Let's see. Levels wise, I think we're good. Maybe I should randomize it again. Nah, it's fine. I'm not sick of this yet, so I'll just keep it this way for now. I just like to have this sort of stuff in the background while I code or something, so that um, I just like to have that in the background because it kind of helps me to focus. So yeah, let's just keep that here, and so we can actually just switch between the problem and the solution this way. We can just close day one's input. Day one is fine. If you want to see what day one looks like, that's this piece of code. So it's not really a lot. In fact, it can actually be collapsed into like a single line or a couple of lines or something. Like a lot smaller than this. But either way, I will just start with day two. So, actually, let me just open it in this. Yeah, cool. Day two, dive. All right, now you need to figure out how to pilot this thing. It seems like the submarine can take a series of commands like forward one, down two, or up three. Okay. Forward X increases the horizontal position by X units. Down X increases the depth by X units. Up X decreases the depth by X units. So forward, down, and up. All right. You're on a submarine. Down and up affect your depth, and so they have the opposite result of what you might expect. That's fine. That's fine. Like you can think of it in negatives, or you can think of it as a axis going positive downwards. That's okay. Um, the submarine already seems to have a planned course. Your puzzle input. You should probably figure out where it's going. For example, forward five, down five, forward eight, up three, down eight, and then forward two. Okay. Your horizontal position and depth both start at zero. The steps above would modify them as follows. Forward 5 adds 5, blah 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 blah. Okay, you have a horizontal position of 15 and a depth of 10. Multiplying these produces 150. Calculate the horizontal position and depth you would have after following the planned course. What do you get if you multiply the final horizontal position by your final depth? Okay, I think this is pretty straightforward, right? I don't really think is complicated at all. Let's just copy that. Let's actually get started with, just setting up the files. So we have source test. So I'll put this in test resources. Let me just create a new file here. New, excuse me. Yeah, new file. Let's call that day two the input. All right, and don't ask again. I'm going to click cancel. I'm going to add all these manually. I know they exist, right? I just prefer adding them from the command line. So we're going to do that manually, right? And we are also going to download the actual thing and store it. So get your puzzle input. Um, copy, and we will paste that into a new file here, which we will call the same thing, dot input. And here I'll just paste this. This is the actual file, right? Cool. And the thing we're going to test is we will actually, let's just go here, create a new Kotlin class. Let's call it day02. All right. And I know it's going to take in a file name. So file name string is going to be there. And of course, the rest of it is just like, to do, like we haven't really done anything with it. That's fine. Also, is the convention to actually not use a space there? Interesting. All right. So it's going to take a file name as the parameter to the constructor. I think, yeah, one thing we'll need to do is let's just create a new test, J-Node4, that's fine. And right, so here we are gonna set up a test function, J-Node4, we're gonna call given test input. Again, like sometimes I would, yeah, so what's the thing? Yeah, so I'm just gonna call that as the final position number, right? So position number is 150, right? So solver equals, yeah, okay. I know we haven't actually defined solver yet, so latent it var solver day02, right, equals day02 with day02 dot test. So we will pass in the test input, right? And what's your problem? Could be private. Yeah, sure. I mean, let's do that. Optimize imports. Actually, wait, maybe not. Assert equals 150 solver dot get final position number. All right, and let's create that over there. Long, not yet implemented. Yep, that's right. I don't know why it's long. That's interesting. 150. Yeah, actually, yeah, long is probably accurate. Wow, I didn't even think of that. All right, so 150L, that's just going to be the convention which we use for long. Not convention exactly. For the string, for the number literals, numerical literals, you have to put an L on the number to indicate to Kotlin, the Java compiler as such, yeah, that it's long. Yeah, so that's fine. So forward 5, down 5, forward 8, up 3, down, blah, blah, blah. Okay. So here all we need to do, right? Of course, like I think we do need to parse the input, right? So we need to input parse, and we will call that as, okay, so we'll create a um, instructions, or what am I going to call it? Directions equals list of so it's going to contain like two things. It's going to contain a number, and it's going to contain just sort of an x or y as the axis, right? So I think we can probably demonstrate that by using move. It's a list of moves, right? Let's create a class. Let's put that inside day2. Let's create a class move, and this is basically going to be a data class, which is going to contain two things, right? One is axis, which is going to be, or is x-axis, or yeah, is x-axis with boolean, and it's going to contain a val magnitude, right, which is an integer technically. I can just write it as a long, right? So that's fine. List of move up. So we gotta do that, right? And init directions equals read file and process, file name, and oh my god, Jesus, man. Ban the bird. What is the problem? In a live stream. Spam. Terrorism? I don't fucking know. Where's spam? No, no, in chat. Yeah, yeah, yeah. Next. Spam. Next. I think it's a bot account. Next. Why are there so many steps? I don't even know what these are called. These are like these fake follower services, right? Yeah, it's blocked. Yeah, okay, close. Yeah, sure. Good lord. Okay, so read file and process. What do you do with each line, right? So each line you kind of want to parse and take out two things. So they're all split by space. So I guess it's sort of like, I think we can do it like this, where we put the direction, comma, or axis, comma, um, what's it called? Magnitude, right? Maybe this is not called, maybe I shouldn't call this magnitude. I think this should be more like val. Yeah, I guess magnitude is fine, right? So axis, comma, magnitude. So val, axis, magnitude, uh, comma, this equals 8 dot split. Um, I think this. What's your problem? Does that not work? Mm, yeah, yeah, you can do that. Yeah, yeah, all right. So it is correct. It is correct. It's not exactly wrong. So this is a string, this is a string, and then of course underscore is like just the rest of it which is unused, right? So we've split with space by space. Occurrences, yeah, yeah, yeah. So that's the character. One or more characters to be used as delimiters. Okay, ignore case. By default false. All right, cool. So we do this and we want the axis. So if axis forward, then in that case is x-axis. So x-axis is horizontal. I think maybe we'll call it is horizontal. Shift F6. Right. So is horizontal, or if it's not, then it's vertical. Right. So if the axis is forward, or rather, yeah, I think I can just do move axis double equals. So if it's forward, then in that case that's that, and magnitude, right? So magnitude equals that, right? What's your problem? Oh, sorry, not magnitude, Jesus, is horizontal. Okay, and magnitude equals magnitude dot too long. There we go. All right. No, that's not right either. That's not right either, right? So it's sort of like the magnitude needs to be, there's an if statement involved there, isn't it? Mm-hmm. Can I split this out? Introduce local variable. That's not what I meant. Remove argument name return. Nah, okay. Let's do. Oh shit. Let's do a thing, right? Let's put yeah. So is horizontal is fine, right? So val m equals if axis. Actually, wait. So I think it's a we need a when case, right? So when axis on the basis of this forward we return move with true its horizontal comma the magnitude is basically going to be magnitude dot too long, right? um and now the next one is going to be what is that, down, and that's just going to be move is false and magnitude dot too long, right? And the last one is basically going to be up, and that's just going to be move um, with false magnitude dot too long times -1, right? There we go. All right. And finally, we need like the else branch where it's just gonna be throw operation not implemented. What's that? Not implemented error exception. Error. It's not supposed to be an error, but yeah. Sup, can you help me start my book? Yes. Use that. There you go. I have started you off. You are now on the path to greatness. Just start with this. You know, put the whole drop cap G and everything. You know, the big, fancy G. Have you seen that? Greetings. So you start out strong. Uh, Chapter 1 Introduction to Type Checking. I'm trying to define the fundamental difference between static and dynamic typing languages. Oh, that's a great place to start with. So what do you need my help with? I'm pretty sure you're aware of this topic. Like we have had this discussion before. Yeah, dynamic typed languages. I get it. Yeah. We have had this discussion before. I can't think of the words. That's writer's block. See, what you should do is just write, just keep writing. All right, and then give it like a half-hour break. Like write for an hour or two. Give it a half-hour break, and then come back and purely focus on editing what you've written without actually trying to write up new prose. Right? If you think of new prose while you're writing it, make a note separately. Make a note separately. This is what works. This is what works. Whenever I've had to write anything that's like long-winded, and this is like professional writer advice as well. It's the same thing. I'm thinking something like the variables have a fixed type versus don't have a fixed type. Uh, mm, sort of, I guess you can say that. I mean, it's just, yeah, static versus dynamic typing is really just that um, the type the typing is statically analyzable, which means that you can actually analyze it without actually executing the code. You can figure out the types of all the variables without executing the code, right? That's the thing. Like you can figure out the types of every parameter, every method, every return type, every variable uh, without executing the code, and that's what statically typed is. Dynamic typing is basically where it's not that, and it can change at runtime based on user input or something like that. So you need to actually execute the program to know what the type of each variable is. That's about it. That's sort of that's like the right way to think about it. But again, like how you want to state it in words will depend on you. Sort of like, I don't know. I can't give you the words to put in your book. I can't. What's that called? I'm not gonna put words in your mouth, right? But yeah, that's just about it, right? So that's what static analyze what static analysis is, right? So like static analysis is what you do without a debugger, right? Once you've reached a debugger, you've already sort of failed, right? Like it's sort of like, yeah, the program's already running now, so you need the program to run to actually get useful data out of it. That's dynamic analysis. That's called using a debugger. But static analysis is basically static typing, static analysis. All of that is before the program even executes, just on the basis of what is written in the code. Are you able to figure out the types of everything? If not, you're not running a dynamic, like you're not running a statically typed language. If you can, then you are. That's just about it, right? Strong typing, weak typing, completely different axis. Strong typing, weak typing is a different axis. That has to do with types being converted and not types being defined. So types can be defined one way, but can be converted in different ways, which are unsafe, and that's sort of where you have your strong versus weak typing connotation, right? Like C is weakly typed. C is weakly typed, even though it's static. It's statically typed, but it's weakly typed. It's one of the rare examples that way. I don't think we have many examples of statically typed languages which are also weakly typed. Weak typing is one of the gripes people have at C. Yeah, lots of gripes people have at C, but yes, that is definitely one of them. I think weak typing is always a gripe. Like I never see a positive to weak typing. I don't think weak typing has ever been something that has worked out well. Um, First time, oh, hey, the concepts of strong versus weak typing aren't well defined, but static versus dynamic typing are well defined. Yes, yes, you are right. You are right on that one. Like, strong versus weak typing, we don't actually have, like, because again, every language chooses to think about these concepts differently, and you have certain conversions, type conversions, which definitely have to be done. So when you consider it from that angle, like, it's sort of like you don't have. Welcome to the stream, by the way. I completely glossed over the fact that this is your first time. So welcome to the stream. What's up? So yeah, but yeah, you're right about that. Like, it's just we don't, like, what you might consider as sort of an implicit conversion in one case. Like, for example, even if you consider, let's say, a language that implicitly converts between integers and longs, right? So you have integers which are being read into a function that accepts long, right? So would you consider that as weak typing behavior? Some say yes, some say no, right? So it kind of depends. So it's just like it's sort of like on that axis you can get extremely strict about your type conversions and force you to specify exactly where. It's like, no, you're not allowed to pass in an integer into a long and things like that. You can do that, or you can be a little bit loose about a few things and just define some, like what Java does, for instance, and what Kotlin does as well, is sort of like there are some rules for primitives in that sense that things that accept longs can accept integers as well, even though longs and integers both aren't defined by classes in Java. They're sort of defined as primitives directly in the language. So you do have some implicit rules in there, but for any classes, actually, you kind of have to have, if you want to pass in and like a type where another type is expected, the rule has to exist that the type that is being accepted is a super type of the class of the type that you're passing in, right? So I can pass in a derived class, something that accepts car. I can pass in a Honda into it, but I can't do it the other way around. So, or any other way, like I can't pass in a train into it, right? So it's like there are some rules around that implicit conversion, a very, very limited set of rules around that implicit conversion, but most of that conversion is explicit and follows very rigid structures that, inheritance structures, basically. So those are the only places where you can auto convert that. So everywhere else, you have to do an explicit cast. Mm, I think it's as simple as if your variables can be implicitly converted into another type when some operator is applied to it, that is weak. Um, Python, for example, never does that. JavaScript does it 100% of the time. I don't think that's true. Like I just mentioned, if you add an integer and a long, um, that's like one of those things which Java, for instance, will do automatically. It will convert it into the stronger type, which is long, right, into the more permissive type as such. So if you add an integer and a long, it'll do that. If you add an integer and a float, it'll convert it into a float. Widening conversions, exactly. So I think and you still consider those strongly typed languages. Again, it's sort of a spectrum. It's what some people like. There's a lot of purism and a lot of weird debate that goes on that front. Like, it's just, yeah. Like some people want to have none of that, absolutely none of that going on, like 0% of that. Python, for example, never does that. I don't think that's entirely true either. I think Python does do it. It's just that at least at the level of the language, what it exposes to the programmer, it doesn't have longs exactly, right? It at the level which it exposes to the programmer, it just looks like a single number, but the underlying implementation of it, because you never actually see how much memory your number takes, right? So it sort of handles all of that opaquely for the user, right? The user never sees or kind of is affected by the underlying mechanism of that. So numeric types are an exception. Yeah, that's the thing, right? So numerics are where you have a problem. For any language that is trying to be a little more memory sensitive, it's going to be an issue um, if you do it the Python way, right? Where you do kind of want to be able to define where your numbers kind of end with respect to storage space. So like for example, it does make quite a bit of a difference when you're dealing with like applications of the scale that we work at, because like you're processing so many numbers, right? It's just that's all we do. We just process numbers. So yeah, that's I think at that point like it starts becoming a little bit of a concern. Mm, C sharp is a good example of contradictions. You can define implicit or explicit conversions. It's mostly statically typed, but it also has dynamic typing. Yeah, I don't know C sharp, but I'm assuming it's quite similar, like in that sense, to Java, which is also you can say. Oh wait, you meant static and dynamic. Okay, completely different discussion. Oh, oh, interesting. Okay, maybe I should learn C sharp at some point. Yeah. Sorry. I was on the strong versus weak typing part, and I was trying to like mention that again. Like in Java, you can add an int and a long, and it works. Yeah. No. Static, dynamic, definitely not. Yeah, Java is like entirely statically typed. Entirely statically typed. Mm, there is, yeah. I mean, you can do weird shit with reflection. Again, I haven't really looked into much of that because like it's at that point you've already lost. um, Yeah, it's not necessarily widening conversions are allowed by many languages that are generally considered strongly typed. Yep. Python numbers are always big ints, except for the pooled ints. -5 through 256 are int sentinels. Wait, what? No way. Okay, I mean, I'm going to defer to your knowledge of Python for obvious reasons, but wow, wait, you're telling me that every single number in Python, even if it's like a super small number, what? Always takes up the space of like I don't know how long can a number get in Python. I always assume that you can just increase the size of the number to like as many digits as you want. Um, that's bad performance wise, isn't it? Arbitrarily large. Yeah, that's what I thought. That's what I thought. So it has to be. Yeah. So but that's what I mean, right? If it's arbitrarily large, it's not like every number is gonna be like a gigabyte in size. It's gonna have some sort of size allocated for it, after which it dynamically kind of increases it. And that was kind of my original point, right? That it does that. No, everything is begins, sure, but the point is like considering that there is no maximum number size. Yeah, so considering that it's not like every number takes up like several megabytes in size, right? It's depending on the number that you are actually storing at any given point of time, the interpreter dynamically figures out how large of a space to allocate for that number, right? Isn't that how that works? Because that's got to be the way that works, right? So that's kind of what I was saying originally, that in any language where you want a little bit. Do you know what a big int is? Not exactly, no. I mean, I know what a big integer is in Java. I'm assuming it has to be similar. What it stores. Yeah, I mean, I don't actually know the exact implementation of big integer in Java, like, but it is something on the it is similar conceptually to sort of storing a number as a string and then back converting out. Um, yeah, exactly. Can be arbitrarily large, just how strings can be. But again, that was my original point. That was my original point, right? That the underlying structure, the underlying size, memory size that is occupied by a number, you don't actually know that, right? You don't actually know that. So that literally was my original point, right? So I mean, we aren't disagreeing here. We have been on the same page. Like this, we aren't disagreeing here, right? We have been on the same page. I just don't know what the underlying specifics are, but the point is, given a number, you don't exactly know what the size is, and that's not something you can plan for, and that has that has repercussions in any software which actually does require you to know exactly how much space you're using on the memory, right? So that's the thing. That's yeah, like the numbers we deal with, we kind of like it's good to be aware of, like, because of the number of numerical calculations, right? So yeah, technically all software can do is process numbers. You're right. That is true. That's not false. But yeah, I mean, I'm just being more specific here. I'm not trying to go for the most generic sense of, okay, yeah, we are always processing ones and zeros, so it's just, we are processing numbers all the time. That's not exactly what I was driving towards over there. But yeah, I'm just saying, like, in any application where you are actually processing tons of numeric quantities, you kind of want to know what the size occupied by each one is, or what it can be. So yeah. C implementation of the big int uses hardware slash word size ints when it can. When they would overflow, it heap allocates. Okay. I should. What software needs a fixed amount of RAM? All software needs a fixed amount of RAM. Like, basically anything, especially anything once it is sort of scaled up enough vertically. If you can't really, like, if you can't really architect things in a way which can be horizontally scaled, and that's true for a lot of software. Like, you can't always architect it, horizontally. You can't keep sort of expanding in that direction. You do need some level of vertical, any level of vertical scaling. At that point, you kind of need to be conscious of how much RAM you use. And I know this because, like, we have garbage collection cycles eating up a major portion of our performance on a lot of the processes that we run with. So it is annoying. It is very annoying, and, like, reduction of the usage of RAM is a huge concern for us. So embedded software, of course, very important. This, but yeah, I'm just saying, like, it affects you both at the smallest scales, like embedded software, and at the largest scales. Everything in between, you don't really care about that much. Um, Given, like, the state of desktop software today, like, that's kind of what it is most of the time, because everyone has, like, fucking 16 to 32 gigs of RAM these days, and it's like, you don't really care about most software or taking up a lot of RAM. But for anything that's, like, really large or really small, you actually do care about how much RAM you use. So of course, the optimizations that you apply are going to be a little bit different on both fronts. Like, on super large software, you're actually going to look at big segments which occupy tons of RAM, and then try and optimize within that, and try to apply sweeping changes. Like I said, like, for example, you might want to just change the container which you use for, like, numeric quantities across the board, and if you do that, like, you will actually see big improvements. We used to use big integers before. Now we use doubles, actually, because somebody figured out that you don't actually need, um, because we deal with, like, currency quantities, so you don't actually need, uh, and it's weird because, like, people say, like, you should never use doubles for currencies. They're not entirely correct about that, because you actually just need 2 points of precision on that, and doubles offer you way more precision than it, while also being in a constrained space, like a predictable amount of, like, storage in terms of RAM. So Alan Turing figured, he was mad enough to think that you can do everything with just two digits. He was right. Turing wasn't the first to realize that. Maybe. I mean, did Turing did Turing even did Turing even, like, envision things in terms of binary? Was that a Turing thing? I don't even think, like, I don't think the Turing machine has anything to do with binary calculations as is, right? It's sort of like you have a symbol table, and you have like these, it's a fixed number of instructions, and then you have, like, a tape which goes two directions. That's the only thing. But, like, infinitely state and operations, exactly. I don't think it has anything to do with binary. I'm not sure, because in my computer science education, at least, like, I don't remember ever seeing a link between Turing and binary operations, right? Like that. I think binary was really more of a consequence of the modern transistor, maybe even before that. But the basic point that it's just least error prone if you have two states, low voltage and high voltage, and you don't really have anything in between. That's sort of supposed to be the reason why we use binary for our systems, right? And not anything else. Like, I think people have explored making, like, three state um, transistors and things like that as well, like circuits which, would be able to detect three separate states, like a 0, 1, and 2. But no one has actually, like, you can pick anything as the base. You don't actually, Yeah, exactly, exactly. It's not the transistor; it's binary because you have to stabilize two voltages, so the hardware is much simpler. That's the thing. Like I know there was some research around trying to do it with three states, but I don't think that ever kicked off much. Like people didn't really give much of a crap about it. It has its advantages, I think, but yeah, but you would have to rethink a lot of things. You'd have to rethink storage, like hardware at the hardware level. Pretty much everything would have to be rethought just to make sure that you don't have any increased errors with three states instead of two. So yeah, that's the thing. With the gradation states, your error rate also increases. That's just it. Bit flips are a lot harder than the recorded bits just going to a slightly different altered state, right? So that's kind of the problem. You can theoretically use anything as the base, any number, literally any number. So okay, I should read the book. Which book is that? Oh yeah, there's that. I don't know. I, I don't remember which book talks about Alan Turing's biography. I think is what you're talking about. I just tri-state. I did study a tri-state switch in my digital electronics course. It was weird. Yeah. That's the one I'm talking about. That's the one I'm talking about. We didn't have that in our courses, but I have come across this independently. Anyway, what am I doing? I've just processed the file. All right, cool. Technically, I don't even need to process the file, but I'm saving this in directions just in case because the second part of the problem, I don't know what it is, and it can be annoying. So it's a little bit better to just process it this way and store the value first um, in a data structure. Um, Annotated to the annotated. Yeah. I've heard of this book. I haven't read this before. I love how the pattern match here looks the same in most languages. What you're talking about this thing? Uh, yeah. I mean, I like Kotlin's when expression. It's quite nice. It's quite nice. The when expression is just when axis is forward, down, or up. You can just do these things, right? So it's horizontal, yes. These two, it's no, but here it's just going to be the positive value, and here it's the negative value. I chose to do the positive value for depth. Um, yeah, almost everyone who did this problem wrote something like that. Oh, okay, interesting. I mean, yeah, I don't think you even need to technically because like you can do this parsing. You can calculate this while you do this, but I did want to save this in the data structure because it'll be far easier to read for the second part of the question as well. So yeah, I prefer just doing it this way. Um, watch Time Lord here come up with like a one-liner for this like in about 20 minutes. Uh, some people in the Python core team came up with this abomination recently. Please send. I would like to, set my eyes on fire. Uh, uh, oh, Pep. It's a Pep. One and two can both reasonably be one-liners in Kotlin. Yeah, potentially. It's just I don't like writing one-liners because I don't like reading one-liners. I kind of get annoyed when I read them. I like write like I mean sometimes I feel really clever while writing them, but then later on when I'm reading them, I'm like, what is this shit? Why did I do this? That kind of thing. Late bound function argument defaults. I don't even know what that means. Late bound function argument defaults. Oh, so default values for functions, but they're bound late bound. What does late bound have to do? Calculated during function definition. Expression to be evaluated at function call time. Wait, you can't do this? You can't do this? I thought you could. No? In Kotlin you can, right? Can I do this? Um, let me just put like for example n I want this to be evaluated, so maybe random oh no, I need to do int equals random seed or whatever 55 dot rand dot next int. I can do this, right? Yeah, I can do this. I'm just surprised that this is not a thing that's already possible in Python. It's not a bad idea, but Python doesn't need every not bad idea added to it. I agree, actually. You're not wrong about that. That's sometimes, yeah. What is colon equals? I don't actually know what colon equals is. Assignment should have been expressions from the start, but here we are. I don't know what colon equals is actually. Issue is a velocity. Assignment expressions. Aren't assignments expressions already? Oh, they are not? Okay. Assignment should always be statements. No. I actually agree with Steve on this one. I don't think. Uh, I yeah. I yeah. I think look, again, in code that I've seen that uses the return value of an assignment, um, I've usually not liked that code too much. But at the same time, I feel like there's no good reason for it not to be an assignment. Not to be an expression, right? So in code that I've seen use the return value of an assignment, it's like I've seen that and gone like I have that immediate urge to kind of split it off into two lines. But at the same time, like you know, I don't see a good reason for it not to be. So yeah, you still can't make something like my dictionary some key colon equals one work because Python just likes it when you feel pain. Optimize imports. Wait, what the hell was that actually? Oh yeah, I didn't need the. I don't need the random thing anymore. That's just bad code. I don't know if I agree. Like I feel like the problem is sometimes when I see things like that, like for example, like I see a loop and the sort of the assignment is basically it's a part of that loop, right? So when I see code like that, I kind of go like maybe I should refactor this, like put it on. But then I think like maybe I'm just thinking this because I'm not used to looking at this, and not because of pure readability as an objective metric. Because I feel like, look, for example, the standard for loop, right? With the for I equals 0, I less than, yeah. So Kotlin doesn't have this loop, for instance, right? Because they evidently decided that this was not readable enough. And I don't think they're wrong, right? I don't think they're wrong. I remember initially when I started writing code, this was always a hard loop for me to get. I used to make a lot of mistakes, but this being less than equal to sometimes, and a lot of other stupid shit like that, you know. But again, like I feel like this is one of those things which is sort of like a programmer primitive, and when you get used to it, at that point it starts becoming readable. And now it's like if I see a loop that's written incorrectly, I can just glance at it and I immediately know that it's wrong, right? Like it looks wrong to me. It just immediately looks wrong when I see one of those. I'm like, wait, why is there less than equal to, right? For like a programmer with less general experience, that might not be immediately obvious, and I understand that. I think it's that particular example is objectively unreadable, but at the same time, it's again a matter of just getting used to it. At which point it starts becoming readable, and then that argument kind of goes out of the window. So readability counts, but 99% of the time when someone says it's not readable, what they really mean is I don't like it. Exactly, 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 exactly. Like I have found a lot of code that is objectively bad, objectively unreadable, like code that is just so horrendous that like rewriting it would be far less effort than refactoring it. I've seen code like that. um but also I've seen like whenever you look at these minor things, like when you look at these things which are just like super small in like it's just like centered around one statement or one line or one function call, at that point I find readability is usually overrated, right? For those things where I find readability usually matters is in the names of variables and functions, where I find that that's kind of a bigger problem, where the names aren't super helpful, like they don't like this one this kind of sucks. But also the questions are convoluted and I don't really have a term in my head for being able to tell like what this number is supposed to mean, since they haven't given it a name, so I can't give it a name. They're just asking for the final position for horizontal number multiplied by vertical number, and I can write that as a long ass function name, but at the same time I feel like it's not worth it for like code like this. But I'm just saying I've seen code like this, like where it looks like this and it's equally incomprehensible, but I've seen shit like this in actual production code, and that's kind of where it's a little bit more annoying. So yeah. Nested ternaries are objectively hard to read, but single ternaries often aren't. That's a good point. Yes, that's kind of the exact same point as I was making. Yep. Totally agree. Totally agree. Hot take, all right. So I feel like Python's list comprehensions are supremely unreadable once you start getting above a certain, like, I think once you start going beyond just the top level, it's just completely unreadable for me. I find, like, normally speaking, they are readable, but it's like you put a list comprehension inside another one, and it's just, oh my fucking god, what am I looking at, like, yeah, like, they're the kind of one-liners that annoy me. I get very annoyed by one-liners a lot of times, like these clever one-liners, and like Python's list comprehensions, I think, are at the top of the list for me. Um, but yeah, sorry, Time Lord. We don't. I don't mean to rag on you here, but that's just the examples that are coming to mind right now. Fuck my life. Um, wait. Let's see. I'm still like further back in the chat because I was monologuing for a while. Here's the litmus test. Give a piece of well-written Python and Ruby to a beginner developer. More times than not, they'll be able to guess what the Python is trying to do, but not what the Ruby is trying to do. Totally agree. Totally agree. I do think you have certain measures of sort of objective um, readability, but also consider, right, that beginner developers are almost like 100% likely to have come from a C-like background, right? The first language they would have been exposed to would have been C, C++, Java, maybe Python, one of those things, right? These are all like C based, and it's just, so understand that their concept of readability and what they're used to is already biased. It's already biased to start off with, right? I say that as a very biased developer myself, right? Like I think it definitely makes sense. Like, in like, it's just that that's what most people are conditioned to believe is readable code, right? A lot of this stuff, and then, like, for example, I know people who have like conditioned themselves to be able to read Haskell, but for me it's complete gibberish, right? Complete absolute gibberish. And I find that they have done a lot of things, like a lot of the decisions that I take offense with for Haskell are basically around the fact that they've actually gone and invented certain constructs that already exist with their own syntax, which is opaque to people who are not already familiar with what it is. So that's kind of the thing. um Even though most people will agree Ruby is a better language, that means? I think what that means is potentially that once you get used to both of them, like Ruby potentially gives you a better experience while writing it, right? It's just like I can get used to Java, I can get used to Kotlin. I still think in certain situations Java is more readable than Kotlin. Day over day, that number of situations that I have in my mind is shrinking rapidly, but I still think certain cases it's like, yeah, I've seen well-written Java code where I've been like, yeah, okay, like in Kotlin I know that this kind of goes into all these weird extension methods which I have to know that they exist, and it kind of becomes a little bit more annoying to follow the code, right? So in those cases, yeah, I feel like Java has a little more of a standardized subset of like what it can do, and the limited functionality sometimes aids in reading and understanding the code. I can look at something and know immediately that I can trust it. Like, for example, over here I have invented an extension thing here called .test, which you'll see over here, right? And that's kind of defined over here because I kind of wanted to take the string day02 and directly put the rest of the path in, right? And that is fine for me, but anyone else looking at this will get kind of confused by this, like, what the hell is this method on a string, right? So I feel like in some cases, but I think, like, um with the thing with Ruby is basically when you get used to it, it becomes easier to understand, like, potentially, and easier to write. But again, I don't know any Ruby at all right? So this is just what I've heard about it. The fact that Ruby is super fun to write, I have no experience with Ruby, like, at all. I haven't even seen Ruby code. Like, I've seen zero Ruby code so far. So yeah, like, literally I don't think I've seen a single Ruby file in my entire life. But yeah. Asking what someone who doesn't know the language thinks is happening isn't a useful metric. Yes, that is also true. That is also, yeah, that's kind of the point I was driving at right now. Like, it's basically like once you get used to the language, your understanding of it might shift to a point where it's sort of like, oh yeah, this is suddenly a lot more readable to me than what that used to be. So but it is, if someone who doesn't understand the language can sort of pick it up, someone experienced in it will find out bugs in it 100 times faster. The cognitive load being lower is true regardless of the experience. I don't think that's true for the exact reasons that I've just outlined, right? Like, I feel like Some languages just take a little bit getting used to. Like for example, I'll still say that Kotlin is not a language for a beginner programmer because there are too many gotchas in Kotlin that can bite you if you're a beginner, but which will not bite you if you're experienced enough, right? And it requires you to know another language to be actually able to fully appreciate it. It actually requires you to know Java, and for a big portion of time, I think that's improving now. It's changing for a big extent. Like I've seen, I keep referencing the documentation occasionally. I find that the number of references to Java have dropped over time, but it still references Java in a lot of places. Like it's kind of because it is like, let's face it, it's built over the same environment. But yeah, but that's again like a perfect counter example because it's sort of like overall Kotlin I feel like has a lot less cognitive load simply because of a lot more modern constructs of the lines being a lot shorter and generally speaking all of these nice convenience things. It's nice to read, but at the same time for somebody who is actually programming in it, if you're newer, there's too many things to learn, too many things to learn. So yeah, really love Python's comprehensions. Yeah, I know that that's a hot take. I don't um I don't I don't think most people agree with me on that one, but I find that Python's list comprehensions are supremely unreadable. Like, I find they're fine if you have just the top level list comprehensions, but even if you include like one nested one, I get completely mind fucked. I'm completely unable to read it. I literally need to pull out a pen and paper to kind of like trace it through. It's like what am I looking at? Okay, yeah, this variable goes here, and it's like that's what my brain becomes a list comprehend. Maybe I'm just reading it wrong. I don't know, but that's just me. That's just me. List comprehensions are that kind of thing that makes sense if you encounter it before ternaries. Maybe, maybe, maybe. I don't know. Ternaries themselves, like I feel like, aren't a very great way of expressing things. I like what Kotlin does. It makes if a statement. So if like it makes the if else thing a statement, and so that kind of solves the ternary problem. Like you can just write it as an if else statement instead. So it kind of works. Mm. You're trying to say that the intuitions of someone who doesn't know the language are a gauge of some abstract, undefinable thing. Rust does the same thing. Ifs can be statements or expressions. Yep. That's true. That's true. It's one of the probably two or three things that I know about Rust. C++ is a very reasonable baseline for unbiasedness. No, that's not true. That's not true. That's not true. You think that way because most modern languages are based on C++. Like they all follow sort of C-like syntax, but that is quite explicitly not true, and it biases you against a lot of functional constructs and a lot of things that other um, sort of other languages that don't exactly follow it makes them seem very difficult to follow, even though that's not necessarily true. Like for example, I'm never going to have an objective opinion on Haskell in my entire fucking life because of all my exposure to C and C like languages, right? So that's just never going to happen. I'm never going to have an objective opinion on Haskell. It's always going to seem a little bit less readable to me because let's face it, that's just the way it is, right? So but I, so I don't know. The problem is readability is a human centric. It's a very subjective argument. So comment about intuitions with a respond to drunk time lord, not you. Okay, yeah, I should have guessed that. I mean, I was trying to figure out if I said something about that, but yeah. Yeah. I guess yeah. Now, I think what Time Lord is saying also makes some very. That's also some super valid points, like in the sense that how a programmer who is fresh to programming to some extent is able, like how quickly they're able to comprehend and how quickly they're able to get productive on a language is one very good metric that you want to have, and that's the reason why a lot of modern languages and also Python, by the way, which is not a modern language, but I'm saying Python, JavaScript, for instance, all of these languages, the reason why they're adopted in a lot of these startups and a lot of firms that move fast essentially and try to build things, maybe not at a very large scale but want to do it quickly, right? The reason why they do that is largely because of that. It's because Python and these other languages allow you to prototype and test and sort of just kind of get in the groove of being able to write software that works super quickly without having a lot of setup, um, without having so it's just in the general sense what he mentioned. That's absolutely right. It's just readability wise, that's one metric. But the other metric with that is basically around over a longer period of time, once your code base starts growing, once it starts getting out of control, etc., what becomes more readable, right? And over there, potentially you might want to stick to languages which have potentially more inherent complexity, but also like are able to handle a lot more thrown at them. So yeah, that's there's a lot of up and down over there. But yeah, like for example, Go, from what Time Lord just mentioned, Go looks a little bit less readable to me than, let's say, Kotlin, for instance. Actually, Kotlin is probably a bad example because Kotlin is very readable, but I'm saying Go looks less readable to me than even Java, right? But I know that that's most almost definitely because of I have a lot of experience in Java. I have none in Go, and so it's like, yeah, I start looking at Go code. I'm like, wait, I don't really understand this at all, right? So that's kind of what happens. Like even that initial intuition kind of um uh, like by intuition it kind of breaks you when you realize that like exports kind of start with a capital letter, if I remember correctly, in Go. And that's not how it is in Java. In Java, classes start with a capital letter, and you export anything which has public on it. That's accessible from the outside of that specific module. So in Kotlin, public is by default, so it's technically I can call this, I can call anything which doesn't have the word private explicitly mentioned, I can call any of that stuff, right? So again, you have some things to get used to, which kind of make you think that something is less readable than it actually is, right? I say all this now, but honestly, when I'm looking at code and all that, like these biases kind of play out in full form. So it's like I don't really think about most of this. At that point, it's just monkey brain Go, right? It's like, yeah, I just stare at code and it's like, what shit is this? Like I don't understand any of this, right? So you should ask Time Lord about how I was ranting about Haskell a few months ago. He sent me like an article, and most of it was in Haskell, and I was like, "What the fuck is this language? I don't understand any of it." Like, it was just like I was like, "This is so horrible." And later, when I calmed down, I was like, "Okay, maybe it's just because I'm not conditioned to this kind of thing at all." I still think it's an objectively bad decision for them to have gone and changed a lot of the definitions of like fundamental constructs like functions and all that stuff. Like I'm like, why not just stick syntactically to C? Like it's just the choice of symbol. Like you can stick to the same symbols, just change, introduce your own concepts into it, but stick with the same symbols. At least that way, like you can ensure that other programmers are able to get what you're talking about. I don't know. But yeah, they've gone and changed a lot of stuff. The syntax is just super weird. It looks super unreadable to me, but I know that it's probably not. Lol, I was able to pick it up pretty easily. Again, I don't know, man. It comes down to like different people, different preferences. Like people are like, yeah, just good at different things. C and the like are coming from the Turing mindset where you start with hardware and work up from there. No, 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 no. I'm not talking about that. I'm not talking about any of that. I'm talking about syntax. I'm just talking about syntax. Like the fact that we put, like I use what's it called, the KNR style braces, KNR style, where you have this on the same line, and then I know others who put it on the next line, and I hate that. It's just this looks less readable to me than this, even though they are the same, right? I do think there's objectively a better reason to use tabs over spaces, though. There are good objective reasons. I think like my stream description itself has a link to one of that, like why I prefer tabs over spaces. There is an irrefutable argument over there. But yeah, I'm like a hardcore tabs person. So you will see that I set tabs to any code that I work with. Of course, like over time, my positions have mellowed. Like I, I tried doing this at work. It did not go down well. So yeah, I don't do that at work anymore. I kind of stick with spaces because that's kind of what the global convention is for some stupid reason. But yeah, I feel like conventions are stupid. I think like you should only pick convention when there's no good objective reason to go one way or the other. But tabs have good objective reasons. So accessibility is one huge reason out of that. I think that's the biggest reason. Accessibility is like probably the biggest reason to use tabs over spaces. So yeah, but for most things like this, I don't think there's a good objective reason either way. Like I feel like this is less readable because it sort of wastes a line, but some people might find it more readable because it leaves a space, like it leaves one line gap in between the function definition and the function's body, which kind of makes sense because that's how you write it in, like, let's say Markdown or something. If I was writing a header, right, in Markdown, so I wrote like header, and then I start my paragraph like over there, right? Fuck, what is happening? I start my paragraph over here, right? So that's kind of the thing. This is one of the situations where less readable just means I don't like it. Exactly. That's the thing. But that's what I mean. Like I'm not talking about anything where you're starting with the hardware, etc., or starting with somewhere and working down. I'm not talking about any of the conceptual stuff. I understand that both Haskell and C have very unique concepts and very unique modes of thinking, paradigms. That's the right word. Very unique paradigms. I'm not talking about paradigms at all here. I'm just talking about choice of syntax, choice of organization of lines and functions and things like that. Just pure code. I don't know if aesthetics is the right word, but I don't think I'm talking about aesthetics specifically, but I'm just talking about the organization of where things go, like your tokens go, right? That's just about it. I think there you do have some objective and some very non-objective arguments, but yeah. Uh, uh, it's not more or less readable. No human would have any problem reading either version. I have a problem when I read these. Like we have this in our code base. My work code base uses this abomination, right? And I don't have a problem when I'm in the middle of the function, but at the start it always bugs me. Like I pause for like an extra couple of seconds and just stare at it, you know. So I don't know. Haskell syntax is more inspired by the maths that it comes from, dude. We did math at school. We did math at school. I don't relate to any of the syntax in Haskell. Like I was literally trying to parse it like a fucking computer. I was not reading that code. I was parsing that code. I was trying my hardest to figure out what it was doing. It wasn't even complicated. That's the worst part, right? It was just some very shitty example code, like very very simple example code. Really? Is that why? Okay. But okay, I don't know. I guess we didn't learn lambda calculus. I don't know if lambda calculus has like, I don't know if lambda calculus has its own syntax in math, but um, all of the math we did learn regular calculus. But yeah, I get it. Yeah, but it doesn't. Want to know something funky? Python standard library is 36% spaces. More objective reasons to have used tabs, bro. Holy fuck. Standard library is 36% spaces. God damn. What? That's a third. That's a whole third. That is insane. Yeah, I find Python's decision to use spaces over tabs even more puzzling because it's a language that actually depends to compile on indentation level. At that point, I'm like, why wouldn't you use tabs? Because the tabs are so unambiguous with indentation level. One tab is one indent. It's super, super unambiguous. With spaces, you need to know how many spaces were used to make each level of indent, which just sounds dumb. Like, I don't know, man. And I'm not trying to be like the fucking like Richard Hendricks on Silicon Valley. And who does this anyway? No one does this. That was so unrealistic. Like, no one hits spaces like this. Everyone uses the tab key and they just set it to output tabs or spaces. That was just dumb, but I'm not trying to be that guy, but yeah, there are good objective reasons. Huge waste of space. Shit. That's true. God. Okay. Oh man. Uh, Lambda calculus has basically nothing to do with normal calculus. Okay. I mean, I don't know. I'm not a math major. I have no clue. Um, to be perfectly honest, I have no clue what that is. But I would be very surprised if it's math. Like, yeah, I would still expect there to be some common syntax with math, right? Like, it's like the stuff you learn in algebra and the stuff you learn in arithmetic and all that kind of carry over. It's just you add more symbols. Like when you're talking about matrices, you have the square bracketed things with the numbers in a grid and a few other things. Like you kind of have like some added levels of syntax, but I'm just surprised that like lambda calculus would have a completely different, because Haskell, that didn't look anything like what I've ever seen. So yeah, calculus is a very generic word. Yeah, that's true. Gist of lambda calculus is that you can have only functions that can take arguments, and that's it. You can build everything from that. I do mean only functions, like no operators or anything. Yeah. Operators are functions, of course. Operators are functions. I feel like Kotlin does a very good job of internalizing that to a good degree, because like you kind of have you can specify like I can take like two numbers and call plus on them, right? So I can write it as 5 plus 6, I think. Yeah, I can write it like this. But this is pretty much the same as 5 plus 6, right? I can write that as 5 plus 6 as well. I think. No, I can't. I do actually have to replace it with an ordinary call. Yeah. I I don't know why. Yeah, maybe this is the only way to express a plus, but yeah. Um, I mean, the math not in the context of a programming language. Yeah, I get it. I get it. I get it. I get it. Like it's the same sort of idea that Haskell tries to bring, right? With pure functional programming, it's sort of the same idea that Haskell tries to bring to the programming world, where you're able to like compute with purely functional transformations. So yeah, of course, like at its underlying level, I think like there's obviously going to be a point where it breaks from that. But yeah, because like computers don't really operate that way, so it does have to go down to the hardware at some point. Plus is a function. Yeah, true, true, true. Oh my god, gotta do this. Okay, so let's see. So exposition, exposition. Okay, so var exposition integer, right? Var y position integer. All right, so for d in directions, if d dot is horizontal, and then in that case, to do, yeah, else to do, right? So if it's horizontal, then it's just forward. So x position plus equal to d dot magnitude. What's your problem? Oh yeah, this has to be a long. What is your problem? Initialized. Oh, I thought equals 0 was assumed. It's not, I guess. Okay. Else y position. I'm pretty sure I can actually just collapse this way more in Kotlin. I should be able to collapse this like way more, right? Like if d dot is horizontal, uh, I don't think you can change the LHS of this. Unless there's like a clever way to do this that I'm missing. I'm trying to see if there's like a neat one-liner for this, right? So probably not. Probably not. Yeah, it's fine. Uh, okay. So this should be it, I guess. What is Kotlin's reduce function called? There are two. There is reduce and there is fold. Can you reduce? Oh, yeah, you might be able to. There's reduce and fold. There are two of them. Yeah, you might be able to one-lined it, but yeah, there's fold and reduce. Like fold has an initializer. Fold has an initializer. Reduce uses the first value in the list as the initial value. So yeah, fold will use the first value in the list. Reduce will use fold will use an initializer that you provide, and folds are more generic than reduce, though. Are they? I mean, yes, I guess. I mean, it's the same as, I don't know, if you prepended the value which you pass for fold, whatever the initializer you pass for fold, if you prepended that to the list of reduce, it's the same thing. Yeah, conceptually, they are exactly the same operation. Nothing changes. Nothing is like conceptually more generic or less generic. It's just implementation details, right? Reduce just needs, like, reduce. The thing with reduce is that if your list is empty, you're fucked. You need to make sure your list isn't empty. So yeah, you can't run reduce on an empty list. Uh, let's see. Okay, yeah. So we can just run that test actually. Um, we should have run this first. I always like to run my tests before I actually write my code, but yeah. For future questions, we'll probably have tests for the different parts of it, but for now, it's just, since there's just like one big piece, we don't really need to unit test anything. So I think we're good. It failed. Oh, minus 150. Oh, I'm sorry. Did I fuck up the signs? I thought I thought I thought down I put positive. And up I put negative. Oh, I put minus equal to. I'm an idiot. Yeah, that's how one line did reduce. So you can. It would be two lines, right? Not one, because you can only. Could you one line it? What would that look like? So that would be directions dot reduce or no fold maybe. I need to pass in an initializer, so I think 0 would be my initializer, and then operation would be ah okay. I stored everything as a 2D vector when I parsed the input, so I could one line it with oh okay. Oh, that's clever. That's clever. I don't know if 2D vectors are a thing in Kotlin. I do remember for last year's Advent of Code, I had made my own kind of class for complex numbers, where I'd done something similar. I'd made my own class for complex numbers last time I wrote. I don't think we have a 2D vector. Maybe mm, parse the input, so I could one line it with directions dot aggregate acc comma x acc plus x aggregate is reduce. Okay, I guess yeah. That would work. Wait, maybe we should just close all the others. Close our tabs. Let's just open the test and we will print part 1 solution. Okay, solver equals day02, day02.prod. So that uses the production file. Assert, no, println solver dot get final position number, and if we just run this, we should have that number, which should possibly be right. There we go, part 2. All right. Based on your calculations, the plan course didn't seem to make any sense. You find the submarine manual and discover that the process is slightly more complicated. You need to track a third value, aim, which also starts at 0. Okay. The commands also mean something entirely different than you first thought. Down X increases your aim by X units. Up X is aim like accuracy? Decreases your aim by X units. Forward X does two things. It increases your horizontal position by X units. It increases your depth by your aim multiplied by X. Oh, fuck. Then in that case, our initial, oh my god, our initial data parsing is actually useless, right? Because, no, it's not useless. It's not useless. We've still just recorded the instructions. We've not done anything else. Yeah, data parsing just recorded the instructions, right? Um, yeah. It just recorded the instructions just with a specific syntax. Okay, so forward X does two things. It increases your horizontal position by X units. It increases your depth by your aim multiplied by X. Okay, cool. Since you're on a submarine, down and up do the opposite of what you might expect. Down means aiming in the positive direction. Yeah, that's fine. Um, Forward 5 adds to your horizontal position. Okay, fine. I'm not going to follow this example, but it finally reaches 900. This is what we expect, right? So let's just pull that up. Pull my boy up. Here we go. Test function given test input. Final. What's it called? We need finally to multiply your final horizontal position by final depth. Yeah, we need to do the same thing. I'm just gonna call this aim position number. Again, all the names are stupid, but again, I have no good concepts for any of this. So solver equals day02 dot test. Assert equals 900 is 900L is solver dot get aim position number. I don't even know what the. Okay, so member function long to do. There we go. All right, cool. And all right, So now if we are gonna look at this, I think again we have an X position and a Y position, but we have to track a third value called aim, right? And var aim equals 0L, right? So actually I can just write those instead of writing long, I can just write this as 0L and 0L, right? Mm, I should probably look to see if like Kotlin has a 2D vector thing inbuilt. All right, let's see. So at this point, again, what was the thing? So down adds 5 to aim, forward, uh, yeah, sorry, down will add to aim, up will subtract from aim, and forward will do two things, right? Okay. So for d in directions, if d dot is horizontal, then in that case we need to do something. We'll come to that. Else, right? So else it's pretty simple. We're just gonna do aim plus equals d dot magnitude, right? That's pretty much all we need to do in the else case. But forward x, we need to do two things, right? We need to increase x position and y position. So x position plus equals d dot magnitude, right? But y position will increase by aim multiplied by x. So y position increases by aim multiplied by d dot magnitude. There we go. All right. And return x position times y position. Cool. I think we can probably just test that out directly. Let's just run everything. Cool. So that this also passed. Fantastic. So print part 2 solution. Um, so no, println solver dot get aim position number. Let's just run you. Boom. 22 milliseconds. Kind of a longer time. There we go. Cool. Day 2. Yeah, that was fairly quick actually for the actual solving. But yeah, productive stream. Actually, I had a very interesting discussion on languages which I didn't expect at all. Thank you, Steve and Time Lord, for joining the stream. Yeah, I think that's about it from me actually, because like it is like 10:30 where I live, and I would like to do a couple of other things before I yeah, we did part 2 the same way. Just during the reduce, I converted to 3D vectors and did the new calculation in the z coordinate. Whoa, okay. Huh, that can be done. That's true. Because you just need to keep track of three numbers and it's just a transformation from that point, right? Do we have n-dimensional vectors? Kotlin? Is that like a thing? N-dimensional array live? I mean, we can just track it as an array for sure, but in that case, we'll need to define the operations for being able to add the arrays and things like that, right? That's kind of the problem that I have. I don't think we can. Can we add to? Maybe we can define it like a data class and define the operations. I think that would be doable, right? Like we can technically define it as a data class. Like let's say, for example, I can have it as I can call it data class position, and I can have x integer 0, y integer 0, and aim integer 0, right? I mean, of course they are integers right now, but um, why did it screw up on the last one? Valvar, for some reason it didn't consider to add the last one. And I can define probably an add, override fun add operator fun, right? Add or plus, sorry, I think it was called plus, right? So what's your problem? Must have a single value parameter. Okay, so position or sorry, other position, right? So if we have this, what's your problem? Plus overrides nothing, really. So it's just operator fun plus. Oh, okay. I think we can potentially define this as return this dot x, or more like fun plus has to return position, right? And we can probably do this as position, or we can just have this as an equals this dot x plus other dot x plus no, sorry, something like that, right? So whoop, yeah, this dot y plus other dot y. um, all right, position of that, this dot, yeah, I mean, of course, like, this is not the actual operation, but yeah, I think you can just potentially define something like this. Oh, but wait, this is to add two positions. Wow, what am I doing? That's not what I want, right? I want to be able to add a magnitude into it. Like, potentially, it's like if I add a horizontal or if I add a vertical into it. No, do I want to add two positions? I'm so confused. Uh, yeah, but of course, like, this third one won't be the same. Like, it's more like, so I'm gonna add either. No, it's more like I will add a move, right? I'd add a direction into it. I'd add a move, right? Yeah, I'd add a move. Mm-hmm. You'll need the plus. No. I'm just thinking like what you need to add, right, into the current position. You'd actually be adding the next move into it, right? So it's sort of like you'd add um, other, which is a move actually, and here you would define it differently, right? So you would be like position. So if uh, so I'll just call this a direction, right? Or I can just call it D, right? Or M for move. So if M dot is horizontal, so here is where I would probably add this stuff, right? Like essentially just putting the position. So it's like you put this. Yeah. So you'd actually base it on, yeah, you'd base it on is horizontal. Like, so essentially if it's true, then in that case you would update the position with these two. Otherwise you would update just aim, and then you just accumulate position, right? So you can actually do this, and you can just add, you can do the reduce using positions instead. Maybe I should refactor. Let me see, like, let me see what it look like for that one. If you have a normal vector 3D with a standard plus operator, you can do it all inside your reduce. Yeah, unfortunately I don't think you have a normal vector 3D. Maybe there's a 3D. hmm, I don't think there's like an inbuilt. I think you have to get some sort of library. That's the thing. Pull in, yeah, that exactly. That feels like overkill, right? For these kinds of problems, it's definitely overkill. That's the reason. Because I'm pretty sure that there is, yeah, there's Romain. Oh, Romain guy. Really, Romain wrote a Kotlin library. Interesting. I had no idea he was doing Kotlin now. But yeah, this, yeah, you can actually do this, I guess. Yeah, actually, it makes sense that Romain guy is he wasn't he an Android person working at Google? That's what I've heard his name, right? Like 99%. Yeah, there we go. Yeah, of course he's working in Kotlin now. Why am I not surprised? Actually, why am I surprised? Um, yeah. Okay. Yeah. So this is the thing. Like, I mean, yeah, you can pull in a library for this, but yeah, that is definitely overkill. I was just trying to see like what is the operation that you would have to define on your own to make that work, right? So, if you have a normal 3D vector with a standard plus operation, you can do it all inside your reduce. Wait, really? How? Like the normal plus operation would just add two vectors, right? So, but you would also need directions that aggregate int vector 3D is 0, so that's the initializer. hmm And you have an accumulator comma vector. I think I can literally copy paste this code in Kotlin and have it work as long as I define this. Mm, ACC plus new int vector 3D x y x times accumulator dot y. So this is the existing y plus um Oh, I see. Wait, is X your... Oh, so X is your aim, and... See, this is why I don't like one-liners, right? It's just so much harder to parse this. Um, so it's like X is... So this is your new aim, I guess. No, 3D. There's a Z as well, right? Here, but you never have Z as an input. That seems wrong. Shouldn't this be Z? Am I reading this wrong? I feel like this should be Z. But also Z is used in the plus operator, which is already defined. Oh, ACC plus, right? Wait. So your final thing is basically going to be acc.x plus v.x, acc.y plus v.y. Okay. And acc.z plus v.x times acc.y plus v.y. So that's going to be, you're going to take whatever is the result on this guy and you multiply that with v.x. So the aim just increments, but if it is horizontal, wait, what? Aim is y, okay. X is just horizontal. Wait, z is the new depth. Oh, right, okay. Ah, right. So your aim just adds. But wait, what if... Oh, okay, but you gotta parse directions differently, right? Yeah. So when you parse directions initially, it's gonna be the directions file initially, it's gonna be anything horizontal is gonna register in X, anything vertical is gonna register in Z, and Y is gonna be 0 the entire time for the entire list. No, parsed as a list of 2D vector. Yeah. It's only you only need a 2D vector for directions. Right. Parsing is just X and Y. But isn't the accumulator supposed to be of type direction in this case? Or am I missing something? No. It's not. No, wait. It is? It is, right? Like, the type of this has to match the type of this, right? Like, the type of this and the type of the accumulator has to match this. Or am I thinking of that wrong? Like, 99% sure that's correct. Accumulator is vector 3D because it uses int vector 3D as the seed. Yes. Okay, is that how it works in Kotlin as well? Wait. I thought... So, directions dot fold initial r. So, wait. Fun iterable t. Oh, okay. Right. So, your initial value doesn't have to match the type of the iterable. It's just this value over here. Sorry, not this. It's just this value here, v, which is going to be taken from directions. Right. Okay. Yeah, that makes sense. Yeah. Now I always find one-liners hard to read. Like brain no work. Brain work very slow. Real bad. So yeah, I always find like one-liners super hard to read. Like it's just one of those things where it's like I'm like staring at it like this, trying to make sense of like what's going on. Sure, it's like definitely very cleverly written, and of course like it doesn't really matter for like advent of code and stuff, but I usually like writing my code like this, like with tests and everything. So yeah. Yeah, fun. Okay. Learned a lot today, surprisingly. Okay, not bad. We actually did a fair bit. I think this read file and process is definitely the most useful thing I did last advent of code. Um, it just makes it so easy to parse the file. Cool. Okay, so yeah, that's about it from me for today. I'll catch you on the next stream, which should be tomorrow at about the same time, more or less. I don't exactly know. It'll all depend on my work. Yeah, I don't think I'm gonna do morning streams for a while now. Like potentially on the weekend for sure. But yeah, this was fun. Thanks for hanging around. Drop a follow if you'd like to catch when I go live next. I think like yeah, there's also the Discord server which we occasionally talk about software, and more or less I use as a platform to just announce when I go live. So yeah, that's about it from me for today. I'll come back for the next question tomorrow, and hopefully, if I have some more time tomorrow, which I probably should, I'll be able to solve some more questions from the past Advent of Code as well, because I think on that we are still somewhere around day 22 or something is what we last solved. No, 21 is what we last solved. We still have 22, 23, 24, and 25 left. So yeah, I do want to finish those as well. So both 2020 and 2021 will be done by the end of this Advent of Code. So that's my aim. I think like most of that I'll be doing on the weekend, but yeah. Anyway, fun stream, a lot longer than I expected it to, 1.5 hours. Cool. Had a lot of fun, learned a lot. Thanks for watching, thanks for being here, both of you. Or if anyone else is lurking in the chat, thanks for sticking around as well. I'll catch you guys in the next one. Bye bye.